now we will look at question number 12 on your Unit 1 test, which was constructing a square using only a compass and straight edge. Now, there are a few different ways you could do this, but at the very least, you need to start by drawing a segment of some kind, because you need to find a right angle. Remember, a square has 4 sides of equal length and 4 right angles. So you can't do this construction without finding a right angle. So I have a segment right here, boom, boom. I'm going to construct the perpendicular bisector of that segment. So I'm going to do one of the main constructions that we did in Unit 1. Swing it through. And swing it through. Now I got a little messy over here. I'm going to want to see... Yep, it's the bottom one of the two, so I'll ignore the top there. So that intersection there and that intersection there of the 2 arcs will be on the perpendicular bisector of the segment that I just created. There we go. Perpendicular bisector here. Okay, so I have my right angle. I might as well, let's see, I could construct a square right here, okay? Well, a square has a right angle. Okay, let me just move my right angle notation over there. So I'm feeling the square should be over there, don't you? Yeah, you feel it? Okay, I have this length here. Okay, I might as well use that as my other angle. Sorry, as my second angle, okay? But first, I'm going to swing this arc to meet this point up here, okay? So if I have a point right here, because I centered my compass over here and dragged my pencil, right, like this here, I'd have the same radius away. These 2 segments are congruent. Between this to this and this to this are the same length. Okay, so let's mark this A, we'll mark this B, we'll mark this C. So AC is congruent to AB. And, you know, I could construct a rhombus to do this. That'd be the fastest way to actually do it. Okay, to save this length here and swing an arc here and swing an arc here, and then I would have a rhombus, okay, which also has 1 right angle, and that would actually be enough to prove that it's a square. But my guess is most of you guys here just constructed more perpendicular bisectors. Okay, so that's what I'll do here, just for the sake of what I anticipate most people doing. Okay, so if I perpendicularly, so maybe what I can do is I can extend this segment, double it basically. So I can get the perpendicular bisector of, of this segment here, and that would pass through B. Okay, so what I just did there kind of off screen was I took this length and I copied it over here. So now I can perpendicularly bisect it and thus create another right angle. So now I have another right angle. Okay, and you're seeing this here, right? I just need to copy this side length as well. Copy here. And I only have one choice. In order to complete the quadrilateral, I need to just connect these 2. And now these will be at a right angle. There are geometry laws that support that. Okay, but it kind of have to be, right? If these 3 lengths are all the same length right here, okay, and then the right angle there and right angle there, well, these 2 lines would be parallel to each other. Okay, and anyways, these are called same side interior angles. They'd have to add to 180. Well, they're both right angles. Okay, so I could have maybe see more evidence of constructing perpendiculars there, but you don't have to. Okay, I have myself a beautiful looking square that I constructed only through compass and straight edge. So I needed to bisect at least 1 segment to really get there, and then I got to see evidence of copying the segment.